In this module, you will learn about the continued proportion. Let's see continued proportion. If the ratio between the first and second, second and third, third and fourth, and so on, quantities are equal, then such quantities are said to be in continued proportion. For example, the quantities A, B, C, D, E, and so on are said to be in continued proportion if A upon B is equal to B upon C is equal to C upon D is equal to D upon E, and so on. If three quantities A, B, and C are in continued proportion, then A divided by B is equal to B divided by C. Here A is called the first proportional of B and C. B is called the second proportional or mean proportional of A and C. And C is called the third proportional of A and B. On cross multiplication, we get B square is equal to A into C, or B is equal to square root of AC. Thus, in a continued proportion of three quantities, A, B, and C, the mean proportional B between A and C is given by the square root of A into C. Let's see an example. Find the mean proportional of 64 and 81. We know that in a continued proportion of three quantities, A, B, and C, the mean proportional B between two quantities, A and C, is given by the square root of A into C. In this case, if the mean proportional between 64 and 81 is B, then B is equal to the square root of 64 into 81, which is equal to 72. Thus the mean proportional of 64 and 81 is 72. In this module, you will learn about the K method. K method states that if every ratio for proportion is taken equal to K, then on cross multiplication, the value of the antecedent will be obtained in the form of the consequent. This method is called the K method. For example, we have four quantities A, B, C and D, which are in proportion. Now the proportion can be written as shown here. Suppose that each ratio can be taken equal to K. Therefore, we have A divided by B is equal to K and C divided by D is equal to K. This implies that A is equal to BK and C is equal to DK. Now, on substituting the value of A as BK and the value of C as DK, the given equation can be solved easily. For example, look at this problem. If P by Q is equal to R by S is equal to T by U, then prove that each of these ratios is equal to P plus R plus T divided by Q plus S plus U. In other words, all the ratios are equal to the sum of antecedents divided by the sum of the consequents. Let's begin with the solution. We are given P by Q is equal to R by S is equal to T by U. Now, by the K method, each ratio can be taken equal to K. Let's take this as equation 1. Equation 1 can also be written as shown here. This implies that P is equal to QK, R is equal to SK, and T is equal to UK. Let's take these as equations 2, 3 and 4, respectively as shown. Now, consider P plus R plus T divided by Q plus S plus U. Using equations 2, 3 and 4, the numerator can be written as shown. On simplification, we get K. Therefore, P plus R plus T divided by Q plus S plus U is also equal to K. Let's take this as equation 5. Now, you can see from equations 1 and 5 that P by Q is equal to R by S is equal to T by U is equal to P plus R plus T divided by Q plus S plus U. Thus, it can be concluded that if two or more ratios are equal, then each ratio is equal to the sum of the antecedents divided by the sum of the consequents. Hence proved. In this module, you will learn about the properties of proportion. Workers in a rice mill are packing rice in gunny bags. Each bag contains 30 kgs of rice. The owner wants to load 15 bags of rice in a carriage van labeled A and 20 bags in another carriage van labeled B. As each bag contains 30 kilograms of rice, carriage van A carries 450 kilograms of rice. while carriage van B carries 20 bags, which is equivalent to 600 kilograms of rice. The ratio of the number of bags in the two carriage vans is 15:20, which is equal to 3:4. Also, the ratio of the weights in two carriage vans is 450:600, which is again equal to 3:4. It means that the ratio of the number of bags is equal to the ratio of the weights. Such an equality of ratios is known as a proportion. Here the numbers 15, 20, 450 and 600 are said to be in proportion. Mathematically, A, B, C and D are said to be in proportion if the ratio of the first two quantities is equal to the ratio of the last two quantities. That is, A:B is equal to C:D. Symbolically, it is written as shown here and can be read as A:B as C:D. The four quantities A, B, C and D are called the terms of the proportion. Specifically, A is called the first proportional, B is called the second proportional, C is called the third proportional, and D is called the fourth proportional of the proportion. In a proportion, it is not necessary that all the four terms should be in the same unit. However, it is mandatory that the first two terms should be of the same kind or should have the same units. Similarly, the last two terms should be of the same kind or should have the same units. For example, in the proportion shown, the first two quantities are in the same unit, rupees, and the last two quantities are in the same unit, kilograms. In a proportion, if the first three terms are given, then the fourth proportional, D, can be obtained as shown here. Thus, D is equal to B upon A multiplied by C. Let's see an example based on this concept. Find the fourth proportional in 2, 6, 26. Let the fourth proportional be X. Then 2:6 is equal to 26:X. On simplification, we get the value of X as 78. Hence, the fourth proportional in 2, 6, 26 is 78. In A:B as C:D, the first and the fourth terms, A and D, are called the extreme terms or extremes of the proportion. The second and the third terms, B and C, are called the middle terms or means of the proportion. If the quantities A, B, C and D are in proportion, then the product of the extremes is equal to the product of the means. Now, let's see the properties of proportions. The first property is known as invert-endo. It states that if four quantities are proportional, then they are also proportional if they are taken inversely. This process is called invertendo. In other words, A is to B is as C is to D implies that B is to A is as D is to C. Let's see the proof for this property. We are given A is to B is as C is to D. It can be written as A divided by B is equal to C divided by D. On cross multiplication, we get BC is equal to AD. On dividing both the sides by AC, we get B by A is equal to D by C, which can be written as B is to A is as D is to C. Thus, A is to B as C is to D implies that B is to A is as D is to C. Hence the property invertendo is proved. Now, let's see an example based on this property. If 30 is to 42 is as 5 is to 7, then prove that 42 is to 30 is as 7 is to 5. Given 30 is to 42 is as 5 is to 7. This can be written as shown here. By the property of invertendo, we can write this as shown. Or 42 is to 30 is as 7 is to 5. Hence, 30 is to 42 is as 5 is to 7 implies that 42 is to 30 is as 7 is to 5. Let's look at the second property, which is called alternando. It says that if four quantities are proportional, then they are also proportional if they are taken alternatively. In other words, A is to B is as C is to D implies that A is to C is as B is to D. Let's see the proof of this property. We are given A is to B as C is to D. It can be written as A divided by B is equal to C divided by D. On cross multiplication, we get AD is equal to BC. On dividing both the sides by CD, we get A upon C is equal to B upon D, which can be written as A is to C is as B is to D. Thus, A is to B is as C is to D implies that A is to C is as B is to D. This proves the alternando property. Now, let's see an example. If 5 is to 25 is as 8 is to 40, then prove that 5 is to 8 is as 25 is to 40. Given 5 is to 25 is as 8 is to 40. This can be written as shown here. On further simplification, we get 1 divided by 5 is equal to 1 divided by 5. Using the alternando property, we write this as 5 divided by 8 is equal to 25 divided by 40. On further simplification, this can be written as 5 upon 8 is equal to 5 upon 8. This can be further written as 5 is to 8 is as 25 is to 40. Hence 5 is to 25 is as 8 is to 40 implies that the 5 is to 8 is as 25 is to 40. The third property, which is known as componendo, states that if A is to B is as C is to D, then A plus B is to B is as C plus D is to D. Let's prove this property. We are given A is to B as C is to D. It can be written as A divided by B is equal to C divided by D. Now, let's add 1 on both the sides as shown. On simplification, we get A plus B divided by B is equal to C plus D divided by D. It can also be written as shown. Thus, if A is to B is as C is to D, then A plus B is to B is as C plus D is to D. This proves the componendo property. Now, let's look at an example. If 4 is to 12 is as 13 is to 39, then prove that 16 is to 12 is as 52 is to 39. Given 4 is to 12 is as 13 is to 39. This can be written as 4 divided by 12 is equal to 13 divided by 39. Now, on applying the property of componendo, we get 4 plus 12 divided by 12 is equal to 13 plus 39 divided by 39. On simplifying, we get 16 divided by 12 is equal to 52 divided by 39. It can be written as 16 is to 12 is as 52 is to 39. Hence, 4 is to 12 is as 13 is to 39 implies that 16 is to 12 is as 52 is to 39. The fourth property is called dividendo. It states that if A is to B is as C is to D, then A minus B is to B is as C minus D is to D. Let's prove this property. We are given A is to B is as C is to D. It can be written as A divided by B is equal to C divided by D. Now, let's subtract 1 from both the sides as shown. On simplification, we get A minus B divided by B is equal to C minus D divided by D. It can also be written as shown here. Thus, A is to B is as C is to D implies that A minus B is to B is as C minus D is to D. Hence, the property dividendo is proved. Let's look at an example based on this property. If 24 is to 8 is as 42 is to 14, then prove that 16 is to 8 is as 28 is to 14. Given that 24 is to 8 is as 42 is to 14. This can be written as shown here. Now, applying the property of dividendo, we get 24 minus 8 divided by 8 is equal to 42 minus 14 divided by 14. On simplifying, we get 16 divided by 8 is equal to 28 divided by 14. This can be simplified as 16 is to 8 is as 28 is to 14. The fifth property, which is called componendo and dividendo, states that if A is to B is as C is to D, then A plus B is to A minus B is as C plus D is to C minus D. Let's prove this property. We are given A is to B is as C is to D. It can be written as A divided by B is equal to C divided by D. Now, by the componendo property, we have A plus B divided by B is equal to C plus D divided by D. Let's take this as equation 1. By the property of dividendo, we have A minus B divided by B is equal to C minus D divided by D. Let's take this as equation 2. On dividing equation 1 by equation 2, we get A plus B divided by A minus B is equal to C plus D divided by C minus D. It can also be written as shown here. Thus, A is to B is as C is to D implies that A plus B is to A minus B is as C plus D is to C minus D. Hence the property componendo and dividendo is proved. Now, let's see an example based on this property. If P is to Q is as R is to S, then show that 2P plus 7Q is to 2P minus 7Q is as 2R plus 7S is to 2R minus 7S. Let's see the solution. Given that P is to Q is as R is to S, this can be written as P by Q is equal to R by S. On multiplying both the sides by 2 upon 7, we get 2P divided by 7Q is equal to 2R divided by 7S. Now, applying the property of componendo and dividendo, we get 2P plus 7Q divided by 2P minus 7Q is equal to 2R plus 7S divided by 2R minus 7S. In proportion form, it can be written as shown here. Hence, P is to Q is as R is to S implies that 2P plus 7Q is to 2P minus 7Q is as 2R plus 7S is to 2R minus 7S.
You have already studied ratio. Let's do a quick review of the concepts. The comparison of two quantities of the same kind by division is known as ratio. For example, the ratio of Rina's weight to that of Tina's weight is 40 kilograms is to 30 kilograms. In the ratio 4 is to 3, 4 is called the first term or antecedent and 3 is called the second term or consequent. Remember some important points. When comparing two similar quantities, check if the two terms are expressed in the same unit. For example, the ratio of 12 years is to 24 years. Both the quantities are in years. The comparison of two quantities is meaningful only when they are of the same kind. For example, it is meaningless to compare 12 girls with 30 apples. A ratio is a pure number and a fraction. For example, the ratio between 2 centimeters and 5 centimeters can be written as 2/5. Now, let's look at two important properties of ratio. If the two terms of a ratio are multiplied by the same number, then its value remains unchanged. That is, if the antecedent and consequent of a ratio are multiplied by a number k, then its value remains unchanged. Let's consider the ratio 2:3. On multiplying the antecedent and consequent by 5, we get 10:15. Clearly, it is equal to 2:3. If the two terms of a ratio are divided by the same number, then its value remains unchanged. That is, if the antecedent and consequent of a ratio are divided by a number k, then its value remains unchanged. Let's consider the ratio 16:64. On dividing the antecedent and consequent by 4, we get 4:16. Observe that the two ratios are equal. Let's look at some types of ratios. The ratio formed by the consequent of the given ratio as the antecedent and the antecedent of the given ratio as the consequent is said to be inverse ratio of the given ratio. For example, the inverse ratio of A:B is B:A. The ratio formed by squaring the two terms of a ratio is called the duplicate ratio of that ratio. For example, the duplicate ratio of A:B is A²:B². The ratio formed by the square roots of the terms of a ratio is called the subduplicate ratio of that ratio. For example, the subduplicate ratio of A:B is square root of A:square root of B. The ratio formed by cubing the two terms of a ratio is called the triplicate ratio of that ratio. For example, the triplicate ratio of A:B is A³:B³. The ratio formed by the third roots of the terms of a ratio is called the subtriplicate ratio of that ratio. For example, the subtriplicate ratio of A:B is third root of A:3rd root of B. The ratio obtained by multiplying the terms of the given ratios is called a compound ratio. Let's look at some examples now. Let's find the duplicate and subduplicate ratios of 49:64 and the triplicate and subtriplicate ratios of 8:27. The given ratio is 49:64. Duplicate ratio is obtained by squaring the two terms. Therefore, the duplicate ratio of 49:64 is 2401:4096. Subduplicate ratio is obtained by finding the square roots of the two terms. Therefore, the subduplicate ratio of the given ratio is 7:8. Let us now find triplicate and subtriplicate ratios of the ratio 8:27. Triplicate ratio is obtained by cubing the two terms. Therefore, the triplicate ratio of 8:27 is 512:19,683. Subtriplicate ratio is obtained by finding the third roots of the two terms. Therefore, the subtriplicate ratio of 8:27 is 2:3.
In this module, you will learn about the comparison of ratios. Vikas and Vinod are friends. One day, they went to a shop to buy pens and notebooks. Vikas had 50 rupees, while Vinod had 100. Vikas spent 35 rupees on pens. Vinod spent 76 rupees on notebooks. Who do you think spent relatively more money from what they originally had? Before you answer this question, let's quickly revise the fundamentals of ratios. A ratio is a comparison of two quantities of the same kind. Given two quantities of the same kind, the ratio between them is given by A:B. In a ratio A:B, A and B are called the terms of the ratio. A is called the antecedent and B is called the consequent. If the terms of the ratio A:B are interchanged, that is, B:A, then B:A is called the reciprocal of the ratio A:B. For example, the reciprocal of 2:5 is 5:2. Let's consider a ratio 2:6 and make some observations. Firstly, write the ratio in fraction form. Now, multiply the numerator and the denominator by 2. We get 4:12. Which is again equal to 2:6. In a similar way, by dividing the first and second terms of the ratio by 2, we get 1/3, which is equal to 2:6. Thus we can conclude that the value of a ratio does not change even if both the terms of the ratio are multiplied or divided by the same positive number. The ratio that we get by multiplying or dividing the terms of a ratio by the same non-zero number is called an equivalent ratio to that ratio. For example, the ratio 10:8 is equivalent to the ratio 5:4. Notice that for a given ratio, there exists an infinite number of equivalent ratios. Let's now learn to compare two ratios. We compare two ratios to know whether they are equal or to know which one of them is greater than or less than the other. Let's consider two ratios, A:B and C:D. Ratios can also be represented as fractions, as shown here. If A by B is greater than C by D. Then, by cross multiplication, we get product AD is greater than product BC, or the difference between the products is greater than 0. Therefore, A is to B is greater than C is to D if AD is greater than BC, or AD minus BC is greater than 0. Also, if A by B is less than C by D, then, by cross multiplication, we get product AD is less than product BC, or the difference between the products is less than 0. Therefore, A is to B is less than C is to D if AD is less than BC, or AD minus BC is less than 0. The two ratios A is to B and C is to D are equal if AD is equal to BC, or AD minus BC is equal to 0. The three results are shown here. Now, let's get back to Vikas and Vinod. To find the answer as to who spent relatively more money from what they originally had, it is clear that we have to compare the two ratios 35:50 and 76:100. This data can be represented as fractions as shown here. These are like the ratios A is to B and C is to D. Let's find the difference between the products AD and BC. It's less than 0. Therefore, 35:50 is less than 76:100. Therefore, Vinod spent relatively more than Vikas. Notice that this method is used only for comparing two ratios. Let's see a method to compare more than two ratios. To compare more than two ratios, the first step is to find the LCM of the consequence of the given ratios. Now, make all the consequents equal. For this, multiply the antecedent and the consequent of each given ratio by the same positive number such that the consequent of the resultant ratio is equal to the LCM. As the consequents of the ratios are the same, identify the greater ratio by observing the antecedents. The ratio with the greater antecedent will be the greater ratio, and with lesser antecedent, the lesser ratio. Let's solve an example to understand the method. Arrange these ratios in descending order 3:5, 4:7, and 7:9. The given ratios are 3:5, 4:7, and 7:9. Represent the given ratios as fractions. First, find the LCM of the consequence 5, 7, and 9 of the given ratios, which is 315. Multiply the antecedent and the consequent of the first ratio by 63. We get 63 by multiplying the two other antecedents from the 3 for which we found the LCM. We get 189 is to 315. Multiply the terms of the second ratio by 45. It is 45 because the antecedent of the second ratio is 7. So we multiply the other two, 5 and 9. The resultant ratio is 180 is to 315. Now, multiplying the terms of the third ratio by 35, we get the resultant ratio as 245 is to 315. Note that 35 is the product of 5 and 7. As all the consequents are now equal, let's compare the antecedents 189, 180 and 245. 245 is greater than 189 is greater than 180. It implies that the ratio 245 is to 315 is greater than 189 is to 315 is greater than 180 is to 315. Therefore, the descending order of the given three ratios is 7:9 is greater than 3:5 is greater than 4:7. Notice that by this method, we can compare any number of ratios and can write them in ascending order or descending order.